Welcome to Ask and Learn.
In this case, we have this flywheel here that is attached to ground through a rod here at its center that can twist. We are given the radius of gyration of the flywheel about its center of mass. And the shaft has a torsional resistance M equals C theta. I guess I used KT here. So let me just, I didn't realize they actually gave us a symbol to use here. Those would be a C, and then these two guys are C's. Most of the time I usually use K sub T as the torsional spring constant. So that the torsional spring constant relates a moment to a twist. So if you twist this bar here, put a torque on it, we'll use the double arrow notation, then it's going to twist about its axis. And that's always kind of hard to draw unless you can draw nice things in 3D. So I just put this here, where this is the moment from between where you disconnected it from the flywheel, and then this is the moment from to ground. So this is equal and opposite to this, and then this is equal and opposite to that, because this has no mass. Theta is positive this way, so we have, let's see here, we have J, the mass moment of inertia times the angular acceleration, and then the moment here is going to be, if we can see here that if we twist it, we need a, let's see here, we have a positive moment here, so that's equal to M, but M is going to be actually equal to minus C theta. And again, we can anyway, they gave us the other equation, M equals C theta, but I basically wrote my moment here as in the same direction as my theta. And in fact, if you want to, one way to think about this is that this moment should always resist rotation. So if I wanted it to be positive, the moment equation here, if I wanted to use a positive, I need to draw this in the opposite direction so that this moment is resisting rotation, so that we have our minus sign here. Either way, it's the same thing. It's just a matter of internally you're using a sign convention that will cancel each other out or not matter in the end. So if we know the radius of gyration, we know the mass moment is this, and so in the end we get K0 squared M theta double dot plus C theta equals 0. Our natural period is then 2 pi times the square root of K naught squared over times M over C, or 2 pi times K naught times the square root of M over C, where C is our torsional spring constant. And this would have units of Newton meters. Newton meters per radian, or force length divided by radians, depending on what units you're in.